This question is from physics chapter capacitor. In this question, we have a parallel plate capacitor and it is filled with in two ways. In the first way, it is filled with a dielectric constant K, and in the second case, it is filled with two slabs of equal thickness of dielectric constant K1 and K2. We have to find the relation between K and K1 and K2. And the question, one more thing is mentioned that capacitance of the capacitor is same. So here, as you see in the figure, we have case 1 and case 2. Case 1 dielectric constant is capital K, thickness is small d. In case 2, dielectric constant is K1 and K2 and the thickness is d by 2 and d by 2. So here, if you look into the second case, so this is the series arrangement. Why it is a series arrangement? In series arrangement, area is not changing, means area is constant. Area is constant. But thickness varies, d varies. And in the parallel arrangement, its reverse happen. In this case, area varies and the thickness remains the same. So based on this information, we can say that case 2 is equal to, it's a series arrangement. So now, if we write the capacitance formula, so we know that C is equal to E naught A by D. And this is used when we are using a medium as vacuum. Now, if we are using a medium where the dielectric constant is K, so C dash is equal to K into E naught A by D. It can be also written as K into C. So if we take the case 1, this case 1 dielectric. So here in the case 1, its capacitance is equal to this relation here. So we can relate it as relation 1. This is for case 1. Similarly, for the case 2, if we have to create the capacitance, so it's a series arrangement and the total capacitance of the series arrangement is 1 by C dash is equal to 1 by C1 plus 1 by C2. We are using the two capacitance, one for this part and one for another part, this one. So here this is our C1 and here it is C2. And capacitance formula we know, it's equal to E naught A by D. So what is the value of C1? C1 is equal to K1 E naught A by D by 2. This thickness is half here. This is D by 2. Similarly, C2 is equal to K2 E naught A by D by 2. This can be also written as 2K1 E naught A by D, and this is again 2K2 E naught A by D. So now total capacitance formula we know, 1 by this one relation we can use. So here 1 by C dash is equal to D upon 2K1 E naught A plus D upon 2K2 E naught A. So what common we can take it out? Common is D by 2 E naught A, and here it is 1 by K1 plus 1 by K2. Now in the question, it is given that the both has same capacitance. So based on that, this value C dash and this value C dash both are equal. Total capacitance is equal. So we can substitute the value of the first one and write it as D upon K E naught A is equal to D upon 2 E naught A 1 by K1 plus 1 by K2. And now we can cancel it out. This D cancel, E naught cancel, A cancel. Further, 1 by K is equal to 1 by 2 K2 plus K1 by K1 into K2. And now we can reciprocate it. K is equal to 2 K1 K2 divided by K1 plus K2. So this is the relation that we get between K and K1 and K2. And this is the answer of this question.